limits to infinity. This limits shows which value does x approaches when it's equal to infinity or minus infinity. First, I'll show an example. In this case, I will have x squared to the limit of x approaching infinity. We have to substitute infinity in x. So what we will do will be infinity squared, which is equal to infinity as well. But this can change if infinity is negative. If we have limit of x approaching minus infinity, and we substitute in x squared, we will have minus infinity squared, which would be the same as infinity. Because as we know, every negative number which is squared is going to be positive. But I'll give another example. If we have limit of x approaching infinity, but if we have 1 over x, this would equal 0. Because as we know, if we divide 1 over 10, this would be equal to 0.1. If we divide 1 over 100, this would be equal to 0.01. And if we divide 1 over 10,000, this would be equal to 0.00001. These equations follow a pattern which is approaching 0 from each of them. So if we happen to have this equation, it would be represented as 1 over infinity. And as we saw, all of these values approach 0. So in this case, it will also approach 0. In this other example, I will show limits to infinity with radicals. In this case, I will have limit of x to infinity equal to x cubed minus 4x over 2x squared plus 4x cubed. In this case, we have to multiply each of these rows by 1 over x and 1 over x. Okay? I'm sorry, I forgot to add the radical here. But it's the same process. Now, after multiplying here, we will have 2x squared over x plus 4x cubed over x. And on the top, as radicals cannot be multiplied this way, we will have to radicalize this expression. So we will have radical of 1 over x squared, as the squared cancels the root and it would be the same as here, and this multiplied by the radical of x cubed minus 4x. Now that we have this, we have to multiply this at the top. That it would be x cubed over x squared minus 4x over x cubed over what we had previously, which would be 2x squared over x plus 4x cubed over x. Now that we have this, we have to see which of these values approaches 0, which in this case could be this one, as the value here is greater than the one that is above. So after taking that value out, we will have x cubed over x squared minus 0 over 2x squared over x plus 4x cubed over x. Now that we have this, we have to simplify these x's, but we subtract this squared with the x, and we cancel this cube with the x, but we will leave an square as well. So we have the square root of x third over x squared over 2x plus 4x squared. We have to cancel this as well. We'll cancel this, and we will be left only with an square. So we have x over 2x plus 4x squared. In this case, we have this value and this value, but as this value is the greatest, we will just not take this one in consideration. So we will have radical of x over 4x squared. In this case, the value which is below is higher. So as in the rule we saw here, this value will be equal to 0. This might happen in several problems, but there are also problems which have solution, a real solution, and that can be made this way, the same this way, but will have another result.